We have to solve for real numbers, the system of the following equations. We have x plus y plus z equals to 0. This is equation 1. We have x cubed plus y cubed plus z cubed equals to 18. This is equation 2. Then x to the power of 7 plus y to the power of 7 plus c to the power of 7 equals to 2058, equation 3. Now, what we are going to do to solve this question, no examiner expects you, whenever you come across this type of question, no examiner expects you to make any of these variables, the subject of honor, substitute into either of the equation, whether 2 or 3. So you are going to make use of an identity in mathematics. So now, the identity is what we are going to use in solving this. So in my previous video, there was a time I made video on a to the power of 3 plus b raised to the power 3 plus c raised to the power 3 then equals to 3abc. Based on one condition, what we made this to be equal to this is a plus b plus c must be equal to 0. It's in my previous video. Go and check. I explained from scratch. So this, how we got this, or what brought about this, is in my previous video. Now, what we are going to do, so we are going to change the letters here to the given letters here, the variables. X plus y plus z equals to 0. That is equation 1. That implies x cubed plus y cubed plus z cubed equals to 3xyz. Now we are going to use the knowledge of polynomial. And this time around, because we are given 3 variables, we are going to use cubic, that is polynomial of degree 3. So we are going to find an equation, so which will be in polynomial form, and that will be degree of 3, that is power of 3. So in which we are going to solve for the root of the polynomial, and the root will serve as the solution to this set of equations that we are given. So now let's take the polynomial t, that is as the variable in the polynomial. P is the function of t equals to t raised to power 3 minus the sum of the roots multiplied by t, variable t, then plus the sum of the root we are using letter a, then t raised to power 2. Then I've explained this one in my previous video too. Go and check, you will see it there. Now plus b, then t, then minus c. Now this a equals to the sum of the root, that is x plus y plus z. Then b equals the sum of 2 root put together, sy plus sz plus yz. C is the product of the root, that is x, y, then c. You multiply together to get c. Now what we are going to do, now since a equals to 0, that is the sum of the root equals to 0, so we have a to be 0 here. We are going to substitute 0. Then the polynomial equation becomes t raised to power 3 minus, then this one has turned to 0. There's no need to write anything there again. We have plus bt, then minus c. The next thing is that with the given information, we can determine the value of c using the identity here. This identity, that is, we have x cubed plus y cubed plus z cubed equals to 3xyz. Now here we are given this to be 18. That is equation 2. So we are going to substitute 18 here equals to 3xyz. Divide both sides of the equation by 3, which implies we have xyz to be 6. Then when you substitute, the polynomial equation becomes t raised to power 3 plus bt, then minus c. The next thing is to solve for b. Now how do we get b? Now what we are going to do in getting this equation, so in getting the value of b, is that we are going to substitute for the root of the equation, that is, we are using x, y, c. We are going to substitute x, y, c into this. Then when t equals to x, so we have x raised to power 3 plus bx minus 6. When t equals to y, you substitute y raised to power 3 plus by equal minus 6. Then t equals to c. We have c raised to power 3 plus bc minus 6. Now what we are going to do here is that, so since when you add this together, each of these equations is equal to 0, we add this one to be 0, this is also equals to 0. Now we are going to multiply, that is, this equation by letter x. We multiply by letter S to determine power of 4. So we are going to take, so let S to power of 3 plus Y to power of 3 plus C to power of 3 equals to S, that is addition will now give us S of 3. So we have S of 3. Now when you multiply this by X now, then by multiplying this by S, we can generalize this, that is S of n plus Y of n plus C of n equals to S to power of n. It can be generalized using this notation here. Now that implies when this is multiplied by X, so that is take this equation multiplied by X, take this equation multiplied by Y, take this equation multiplied by C. So by multiplying this equation by X, we have X multiplied by, we explain this one, then the remaining one I will just simplify without explaining this. I want to explain this one so that you can understand what I mean. So when you multiply X by X to the power of 3 plus BX, then minus 6, then the other side when you multiply by X2, you are going to have 0. 0 by any number equals to 0. You are going to arrive at X raised to power 4 plus BX squared, then minus 6x. This is what you are going to arrive at. So equals to 0. Now when you do the same thing, you multiply this equation. Let's call this one equation 4, equation 5, equation 6. Now when you multiply equation 5 by y, you are going to have by y will be y raised to power 4 plus by squared minus 6y equal to 0. Then equation 6 by c, then we have c raised to power 4 plus we have c squared, then minus c equals to 0. Now when you add together, adding this together will lead to s to power, so that is s subscript 4 plus, now adding this together, b will be a common factor, then this is power of 2, that will be s subscript 2, then minus 6, then adding this together because the power is 1, the power of the variable is 1, you are going to have minus 6, because when you take 6, it will be addition of this. 6 will be a common factor, minus is common to all, then you are going to have s subscript 1 equals to 0. That implies we have s of 4, that is, what implies that s to the power of 4, y to the power of 4, c to the power of 4 equals to, so which we are not given. Then when you take this to the other side, you are going to have this will turn to minus b, then s2, then plus 6s1. So this will be s squared plus y squared plus c squared. S plus y plus c. Don't forget, s plus y plus c will be 0. So we have this one to be 0. Therefore, this will turn to 0. S1 equal to 0. Whenever you see S1, we are going to use 0 there. That implies S4 equals to minus B S2. This has turned to 0. Now, we are going to multiply by 2 to get S of 5. So we are going to multiply because we are going to S of 7. We multiply by S of 2. When you multiply by S of 2, you are going to arrive at, so you are going to arrive at multiplying this by S of 2, it will give us S of 5. So this by power of S to power of 2, this by Y to power 2, this by Y to power, the same thing applies here. This will now be B, that will be plus B. Then the power here will now be 3. So that will be S of 3. Then this will maintain 2, that because we are multiplying by power of 2. So now be minus 6. Then we have X to power of, that is power of 2, Y to power of, that will be S2 equals to 0. Because it's going to be 0 there too, because we are having 0 here. Now that implies S to the power of 5 equals to, we are going to take these two to the other side of the equation. We have minus b s to the power of 3, then plus 6 s to the power of 2. Then that's what we are going, because on the other side we have 0 there. Now let's determine s to the power of 2 with the information. How do we get s to the power? Don't forget, s to the power of 2 I said is s squared plus y squared plus c squared. This is s to the power of 2. Now how do we get this? Now by the time we expand s plus y plus c to the power of 2, that is squared, you are going to have s squared plus y squared plus c squared plus 2xy plus 2yc plus 2sc. Now in this case, this is set to be 0. We have 0 here because some of the variable is 0 from the given equation. Then here we have s to the power of 2, then plus 2, then we open bracket. We want to determine sy plus, that is plus 2. Then we are going to factorize 2 out. and it has been factorized out here. We have xy, then the sum of the product of two roots put together. So here we have seed, s seed. Now we have sy plus y seed plus s seed. Now we want to determine the sum of the two roots put together. So now how do we get the sum of these two roots put together? So we have s of 2 here, then we have it. Then we want to determine s of 2. Don't forget sy plus y seed plus s seed. That is sum of two roots put together. We are denoting it by letter, so letter B here. So we have 0 raised to power 2 is 0 equals to s2 plus 2 multiplied by b, because sy plus y seed plus s seed will give us b. Then we have b here, which implies when you take b, 2b to this side, you have s subscript 2, that is x square y square c square to be minus 2b. Now here we can substitute to get s, but we are going to s to power of 7. Now let's multiply once again by, since we don't need power of 6, let's multiply by power of 4, because here we already have power of 4 to be minus bs2. Now we are going to multiply with power of 4 so that we can get power of 7. When this multiplied with power of 4, so this is multiplied with power of 4, that is s raised to power 3 by s raised to power 4. We are going to have s to power of 7 so that we can use this value that we are giving there. Now in this case, multiply this by s to power of 4, we are going to have s to power of 7, so plus, then we have b, then this will now be s to power of 5, s to power of 5, then minus 6. We are using s to power of 4 here, you'll be having s to power of 4, then equals to 0. Then this one you multiply with y raised to power 4, you have y raised to power 7 plus b y raised to power 5 minus 6 y raised to power 4 equals 0. Then this multiplied by c raised to power 4, you have c raised to power 7 plus b c raised to power 5 minus 6 c raised to power 4 equals to 7. When you add this together, you are going to have s of 7, which is equal to 2058 there. Now plus, when you add this together, you are going to have bs of 5, then minus 6, then when you add this together, you are going to have s of 4. This one is to save time. If you are to be writing s raised to power 5, y raised to power 4, c raised to power, it will take a lot of time and a lot of space. That's why we are using this method, so to reduce the work load. So we have s to power of 7 here. By making this subject of formula, we have s to power of 7 equals to this coming to this side, plus we change to minus bs to power of 5, this will change to plus 6 s to power of 4. Now in this case, so we have s to power of 5. So here we are going to substitute so that we can get s to power of 7. Then the same thing applies to s to power of 4. We substitute this one too. S to power of 4 will also be substituted. Then we have equation 6 already here. Then turn this one to equation 7, and this will be equation 8. Then we have equation 9 here. Equation 9. So we are going to substitute equation 7 and 8 into equation 9. That is, put equation 7 and 8 into equation 9. We have, so that is, whenever you see s to power of 4, you are going to use minus b s to power of, so s to power of 2, that is, we have this one here. So therefore we have s, that is, these are the power of 7, that is s to power of 7, y to power of 7, c to power of 7 equals to equation 7. We are having minus b s5, and s5 is in equation 8. So therefore we have minus b open bracket. So we are going to substitute this value there, minus b s3, then plus 6 s2, then plus 6s4 and s4 equals to minus b s2. So we are going to open bracket and simplify. So we have s7 equals to minus b by minus, that will be b squared s3, then minus 6b s2, then here we also give us minus 6b s2. So therefore we have s7 equals to b squared s3, then minus 12b s2, 12b, then s2. That is s squared. We are having s2, and s2 is minus 2b. Then we are going to substitute minus 2b here. Then here we have x7 equals to b squared x3. So that is x raised to power 3, y raised to power 3, c raised to power 3. So therefore we have 18 here. Then minus 12b. Then x2. We are having x2, that is the power of 2. x2, we are having x2 here. And x2 equals to minus 2b. So we are having this. We are going to substitute this one to minus 2b, then minus 2b. So let's simplify for that. We have x7 equals to 18b squared minus, that is minus and minus will be plus. Then we have 24b squared. When you add together, you are going to have 42b squared. Now let's substitute. We have x7 to be 58 equals to 42, then b squared. Divide both sides by 42 by 42. This cancels. It implies that b squared equals to, when you divide by 42, so let's say 6 goes here, 7. 6 in 20, we have 3. Remainder 2. 6 in 25, we have 4. We have 4. Remainder 1. 6 in 18, we have 3. Now 7 goes here, that will be 49. So therefore b equals to plus or minus square root of 49, that will be 7. So we have gotten b. Now back to this question that we are solving. So we have p of t, which is equals to then t cube, then b. Now in this case, now we can use plus 7 or minus 7. Let's check for plus 7t, then minus 6. We have gotten c to be 6. And we can also use pt, then equals to t cube minus 7t minus 6. Now, in the first equation, because we have to solve for real. So when you look at it, this one is increasing, where this one is decreasing. Therefore, there is no resolution for this one. So we have only one resolution. We have only one resolution here, and which will be in decimal 4. We have only one resolution. Let's check the other one. Now, in this one, let's check whether we have integer solution here. This one, we have only one resolution. Then we are using this one. So that is, we have pt equals to t raised to power 3 minus 7t minus 6. Let's check for t equals to 1. P1 equals to 1 cube minus 7, then minus 6. Then that one cannot work. Let's check for t equals to minus 1. So minus 1, then we have minus 1 raised to power 3, then minus 7 into minus 1, then minus 6. So this one will lead to 0. Therefore, we have p of 1 to be equal to minus 1 plus 7 minus 6, which is equal to 0. So in this case, we have t equals to minus 1 is a solution, which implies t plus 1 is a solution to the equation. Then we are going to divide the polynomial using division of polynomial. We have t raised to power 3 minus 7t minus 6. Then we have t plus 1. So t goes in t cube, we have 3 raised to power 2. T by t, we have t cube. Then 1 by t squared, we have plus t squared. When you take away this cancel, we have minus t squared. Then minus 7t, you bring this one down, minus 6. This goes here, we have minus t. When you multiply, you are going to have t minus t squared. So it will be minus t squared. So multiply by this, that will be minus t. When you take away this, cancel this one, you have minus 6t minus 6. This goes here will be minus. When you multiply, you are going to have minus 6t, then minus 6. 0 is left. This by this minus 6. This t by minus 6 minus 6t. So minus 6 by plus 1 minus 6 is 0 is left. Therefore, so we have the factorization of this to be t plus 1, then multiply by t squared minus t minus 6. So when you factorize continuously, you are going to have t squared, that is t plus 1. So, and this one will give us t, then 2 by 3, 6, minus 3 plus 2, that will be minus, that is plus 2, then minus 3, t minus 3. So therefore, this leads to t equals to, so we have this one to be 0 now. This equals to 0. We have t equals to, that is t minus 1, t plus 1 equals 0, t plus 2 equals 0, then t minus 3 equals 0, which implies t equals to minus 1, then t equals to minus 2, then t equals to 3. So therefore, this can be permutated in 6 ways, that is 6 factorial, because there are 3 sets of solutions and it can be interchanged because the equation is symmetric. Then we have x, y, z to be equals to -1, -2, 3. Then -1, 3, -2. Then we have -2, -1, 3. Then we have -2, 3, 1. We also have then 3, then -2, -1, and the last but not the least, we have 3, then -1, then -2. These are the set of solutions. In fact, we can determine any set or part of x, y, z. That if you are asked to determine then x raised to power 4, y raised to power 4, z raised to power 4, you can do that with the information that I are given here. So therefore, we have x to be -1. So we can take -2, we can take -3. Then we have y to be, so y can take so x equals to -1 here, -2. Then here we have -1. Then here we have 3 here. Then here will be 3. Then z. So we have 1. This will be 3. Then this will be, and this will be 3. We have -2, 1. Then 3. Set of equation. Then here we can have. Then this can take -2 as well. So let's use 3 here. Or -1, 3. Then this one is 3. Then this one -1, -2, 3. -2, -1. This can also take 3. That is, take 3 twice. 3, 3. Then this can take -2. So we have this set of value that x can take if x equals to -1, y equals to -2, and z equals to 3. So it will work. If x equals to this, y equals to this, it will work. X equals to this, then y equals to -1. This will work. When you check in the equation we are given, you are going to see that you have this equals to this. Please like, comment, and share. Love you.